All right, so if anyone ends up watching this at home, we took these 3 quizzes for the first part of this hour and then went over and I forgot to record, but no one watches these videos anyway, so who cares? Moving on. All right, are we here on page 12? Page 12. I got you, don't worry. Oh, I'm going to guess about right there. Oh, it's so weird being amazing at everything. I don't know. Meekum probably knows. It's rough, huh? Just say yes. Yep. Here we go. Concentration. Oh no, is it not sitting upright? Here. This was a good iPad holder before, wasn't it? Yep. Concentration, it is the amount of solute dissolved in a given quantity of solvent at a given temperature. Okay, there's your definition. On this exam, you don't have any matching terms or anything like that. You have straight up math. Now, some kids like that. David was pumped this morning. He's like, I don't have to memorize terms. Nope. You have to know how to type on your calculator. All right. But anyway, here is the definition. But when we go to talk about concentration, we use a couple of main ways of stating it. First is qualitative, which means we just describe it with words. So dilute, we say that's a solution containing a relatively low amount of solute. So like it's watered down. If you were going to make lemonade and it didn't taste, it was like really watery, you'd say it has a low amount of mix in it, or you would say it's dilute. Versus concentrated, the solution contains a high amount of solute. And those are those perfect lemonade stands you roll up in the summer in your driver's ed car. You get it and it almost comes out as a solid. You're like, this is gonna be good. But then you eat it with a chocolate chip cookie and those don't really mix very well, but whatever. So these are just using words. But our test is a math test. So we are going to talk about the quantitative ways to state concentration. And that is described with numbers. All right. There are 3 ways in this class that we will learn how to state the concentration of something. This one, you kind of already know how to do, even though you don't know, you know. And then there's molarity. This is today and tomorrow, I'm sure. And then we'll do some of this tomorrow and this Friday, right? It's Wednesday. Yeah, it's late start. I'm dumb. How about late start for the rest of your life, maybe? I'm all right with that. Okay. Now, so molarity. And I'm going to teach it a little different this year. We're going to see how it goes because kids ace this test except for they bomb molarity. So molarity is the number of moles of a solute dissolved in 1 liter of solution, not solvent. Now that's just, in AP, we really have to hammer this part, but it's fine. I'm going to tell you the volume. You are going to calculate the moles, and then you divide them and you get molarity. All right, so molarity, it's a new unit to you. It's a capital M, but capital M really means the moles divided by the liters. All right, now, these 2 first examples are pretty simple. It says enough water is added to 2 moles of glucose to make 5 liters of solution. So I take my moles, which is 2, and divide it by my volume, which is 5. All right, so that would be liters of solution. 2 over 5 is 0.4. Now, if that is all we would do for molarity, no one would ever struggle with that. You just take the moles and divide it by the liters. but it's more complicated. Now the second one is, it's not too bad. We just have to do, oh, sorry, we haven't done the first one. That was the example, these two problems. So what is the concentration in molarity of a 2.5 liter solution containing 1.3 moles of ethylene glycol? Write the setup and then check your partner and see if they write the same setup. 2.5 liters and 1.3 moles. All right, I'm going to turn a light on so the calculators work better. Okay, so the setup, if I give you moles and ask for, or sorry, and volume and ask for molarity, it's pretty easy. 1.3 over 2.5. Who had that setup? No? Did you take 1.3 and divide it by 2.5? All right. All right, that was a good stretch. Okay, and I don't know, I'm just going to say that's around 0.5. Number two, this one's trickier. What is the molarity of 800 milliliters? How dare I do that to you? Containing 0.25 moles of salt. So I have 0.25 moles divided by 0.8. 0.8. I'm going to show you. All right, to go from milliliters to a liter, you move the decimal 1, 2, 3 places. And we're going to do that a ton. So just try and memorize that. You move it 3 places. And to go from milliliters to a liter, the answer is always smaller. So 0.8 is definitely smaller than 800, right? Because I do get some kids, they're like, all right, it is 800,000 liters. They go the wrong way. So just remember, when we make these, the liters are always smaller, 3 decimal places smaller. Okay, so here we go. 0.25 over 0.8, I don't know, it's roughly 0.3. Oh, it is 0.3? And then I should put a capital M. Now, really, it's annoying. I mean, I like that it's a capital M because that's easy to write, but it's really 0.3 moles per liter. This, and it'd be a 1. This thing is a ratio or proportion. What do we do with those things? We put them in picket fences. That was sign language for picket fence. Okay, got it. Here we go. Now, because, oh my, because molarity is a proportion, it can be used in the picket fence to solve more complex problems. For example, salt contains 0.9 grams of NaCl per 100 milliliters of solution. What is its molarity? All right, this is where I'm going to teach it different this year, and we're just going to see how it goes. All right, so have I given you moles in this problem? No, but what is molarity equal to? Moles over liter. All right, we're going to do it in a 2-step process instead of 1, and I'm going to see how it works. So in order to find molarity, I first have to find moles, which I've been doing for 2 days now. So I look up here and I have grams of NaCl. We okay with that? Now, the book is different, so just kind of watch up here. The first thing I'm going to do is solve for moles NaCl. I take my given, and it is 0.9 grams NaCl. We've been doing this. What unit, tell your partner, has to come down here? What unit has to come down here? Grams of NaCl. Whoops. Grams of NaCl. Where do I find that number? From the periodic table. So I take Na plus Cl, which is 23 plus 35.5, and that's 58.5 grams per 1 mole. So right here, 58 grams per 1 mole. Okay, now what I want you to do is take 0.9 and divide it by 58.5. 0.015 moles. But to get molarity, I have to divide that by the volume. Well, what's the volume? It told me right here, 100 milliliters, so I go 3 places, 0.1 liter. Now, I don't expect this to have been rock solid yet, but hopefully in a few more examples, we're pretty solid on it. Okay, so I did it in 2 steps. The first thing I did is I found the moles. Yeah, it's 0.15 is the answer. Okay, step 1 is I found the moles from the grams. Step number 2, divide by volume. And then I'm there. Moles over liters. Okay, we need another example, right? So let's look. Don't worry about all the notes in the middle between 1 and 2. Just go to number 2. It says, uh-oh, did I not? Oh, Tom Davidson. Oh, I have it just in a super stupid order. Okay, here we go. Number 2, it wants molarity. Please follow along. So I want to know the moles per liter or molarity. What was the first step I did? Step 1, I solved for moles. Step 2, what did I do? Divide by volume. And that has to be in liters. Okay, please, the amount of silence means you're probably a little confused. Just keep with me for a little bit longer and we'll get it together. Okay, so I have to solve for moles. An aqueous solution has a volume of 1.8 liters. Well, that's going to come down here, right? I'll just put that right there right now. It contains 46 grams of glucose. There's where I start my picket fence. 46 grams of glucose. I'm just going to put a capital G. All right, what am I solving for? Moles. So what has to come down here? Grams of glucose. Now, this problem was nice because it just told you, hey, the gram formula mass of glucose is 180 grams per 1 mole. So now, I take 46 and I divide it by 180. 0.25. Awesome, thank you. 0.25 moles of glucose or sugar, by the way. All right, and now step 2, what do I need to do to that? Divide it by 1.8 liters. And I will end up with my moles per liter equaling Okay. Do me a favor. Don't cross it out, but don't move on to 4 yet. Don't cross it out. But will you try number 3? This, by the way, is 0.8 liters. Then try number 3. You got to find sodium acetate. Hold on, let's see if Siri can do it. Hey Siri, what's the mass of sodium acetate?
The answer I found is 82.004 atomic mass units.
82 sounds good to me. Okay, see if you can set it up. Oh boy, I didn't realize we're low on time. We're low on time. Oh. Okay, super low on time, I didn't realize. So I'm going to take 32.4, 82 and 1 mole. Anyone already typed that in? What'd you get? 0.39 moles. And then the second step, divide by the volume, which was 0.8 liters, and you get okay, real quick, give me 5 if you're perfect, 1 if you're completely lost. Don't flip me off. Okay, we'll definitely do more of these tomorrow. Okay, we'll lock them in. Thanks for being awesome as always. You guys are fantastic.